Okie doke. Is there anybody new in the room? Is everybody here from last time? You're new? What are you doing here, man? You just picking on me?
Yeah.
No problems, right? Okay. All right. So this is the second session. So you guys went through the first session. This one's even going to be a bigger roller coaster. So we'll see how this one works out for us here. So if you're here, this is for equations or configurations and equations and global variables and design tables and all right. So we got that one involved. So we got this here, and one of the things I want to talk about is configurations. You're probably not going to like what you're going to hear here. All right. So what's available in assemblies? We got suppression states. Dimensional controls as well too. If you're in the first session, this was something that I talked about with parts, and it's pretty much the same thing. I mean, you can control a lot of things with design tables and configurations. You can switch materials out, you can modify your file properties, you can do lots of things. So don't take it away as such that you can only do suppression states and dimensions, but when you're dealing with this kind of stuff, I'll guarantee it's probably like the 95%, or this is what you're going to be dealing with on a regular basis. If you're just in here, they seem familiar, and that's because they are familiar. It's a common subject across the board here when you're getting in there with the configurations. You may not like to hear what you may not like what you're going to hear. I'm going to show you some stuff, but when I kind of mentioned this in the last one, I'm kind of on the fence about configurations. So, I know I'm supposed to be up here representing, SolidWorks and stuff like that, but at my core, I'm a user as well too. I've been with the software for 21 years, so I've seen it from its infancy before we had configurations and surfaces and stuff like that, and to see where it's come today. And I remember when we first got configurations, it was like, wow, that's going to be great because I won't have to take up more room on my 100 meg drive, so I can keep it all in one place. But, today, there's people that are running, 3-5 terabyte hard drives, and, it's nothing to have, a couple gig of whatever out there. That's kind of small and stuff like that. So the configurations actually do work really well. And I've mentioned in the past and stuff like that as well too, which is, I had a good question earlier, which was how do you, when do you not use a configuration and create a new part, maybe with configurations and stuff like that? And I have to say it really does come down to the mob mentality type ideal. If you don't have everybody on board, if everybody doesn't have the same usage or the same, the qualities as far as how they work and what they do and even experience level, I find it a little bit more difficult to deal with it. Some of the issues that I've run into in the past, especially when we're in assemblies, is I had a tube that was used in a chassis, and the hose went from the engine to the front, and that's all it was. Different lengths, but the problem was sometimes it wound around here, and sometimes it went through here, and so every time we made a new configuration for this part, I can guarantee you that something else broke. Well, this tube was used in hundreds of our chassis, and every time something went wrong in one of them, all the other chassis now blew up because something was wrong, and we never caught it when it went wrong. We always caught it after it went wrong, and you go back to the person who might have done it, and they're like, oh no, I didn't do it. Everything was fine on my side. And we kind of talked about this in the other session, which was, when you're working with configurations, you want to kind of back check some stuff. You want to make sure that the other things aren't screwing around and getting messed up and all that good stuff. But when you get to 300 configurations, even when you get to 50 configurations, it's a little difficult to do that. So you're not going to like what you're going to hear thing is that I'm not a big fan of these. Now, they do work. I will show you some of the work that we can do with them and how they work out. And you'll see that some of the issues that you might run into. Now, if you're a single user or if you're a tight-knit group of a couple of people, they actually work out really good because you have lots of streams of communication going back and forth. How many guys are working with 10 or more people on a regular basis? Okay, just one of you guys. All right, so 5 or more. A couple more people. All right. So there's a good chance that you can get away using these configurations because you'll have greater control. And really what it comes down to is it's not the fact that it can't be done. It's the fact that not everybody has your skill level in certain places. In fact, we might even switch that. Someone else might do something that's beyond your skill level. Okay. So it's a matter of communication. It's a matter of training. And I don't mean come on into the bar training. It's a matter of internal training, showing people how to use it, making rules and regulations. Like, well, we'll use it for this, but I don't think we should use it for that. And if someone else wants to use it for that, then have a discussion. If you want to, that's really when your bar will come in. If you have a support system or anything like that, talk to them. Go to the forums, put that out there. Hey, I got a question. What do you guys think? I'm trying to take a poll of what I can do. You'll get some information. So, always kind of look out there for that. Now, with that being said, I'm going to go ahead and open up an assembly here. Hopefully not as much typing, guys, either. Here's my fancy grill. Dun, dun, dun. How many of you guys have taken the advanced training course with SolidWorks? Anybody? Oh, good. Then you've never seen the grill. So this is a grill I made up the other day. It's the charcoal. Get it? Because I'm Ryan Cole. Charcoal. No? Okay. Yeah, I know it's lame. Thanks for at least groaning. All right. And what we have here is we've got a couple of parts in here. We've got assemblies. And it's a fairly full detailed assembly out here. Now, some of the things that I want to do with my grill is I want to give the user or the owner, I want to give them some options out there, all right? So in this particular case, I have the main option here. And, I'm looking at it like, how can I differentiate myself in the market? Well, here's the mahogany panel on the side. You can see the two little panels to the side. We'll offer them mahogany because it's nice and sexy, right? But then we're looking at it, we're like, that's kind of expensive wood, so let's make a pine one too. And we're like, okay, yeah, because that's really super cheap, right? And then we're like, oh no, let's even do better. We'll give them a mid-range one and we'll make an oak one as well too. So I've developed all these little panels that are coming through to have mahogany and panel, all this good stuff. And ultimately what I have here is you'll see the lack of configurations at the top level here. Okay, I have one configuration in there, but it's what I would call a full configuration. It means all the fasteners, everything's being shown. A lot of times what I use configurations for at assemblies is really for simplification processes. I kind of go back to my roots as an RV chassis designer. Basically, I made glorified truck frames, and it's amazing the number of bolts and washers and nuts that keep those frames together. So, we would have a couple thousand nuts, washers, bolts, all that stuff coming together, and we didn't want it on all the time. It's a lot of geometry, and I know that there's a lot of people that'll come in through and they'll say, hey, look, we don't use fasteners or whatever, but we were very cost conscious and we had to have those in there for our bombs, for our pre-sales, for our post costs. Everything was there, so we wanted to make sure everything was there. The downside was I worked on the frame group, so I had to deal with all the fasteners all the time. So I'd usually run with two configurations. I would have one configuration simply showing me everything put together, and then I'd have another configuration with all the fasteners grouped into a nice little folder, similar to what I have over here, that I could come down, right-click on, and I would have the suppression state right there. Anything in that folder would get suppressed, just like that. So it was very easy to go, hey, here's the light edition of it without all that extra geometry. And then if one of the bosses came through or a customer came in and, it's amazing the detail that a customer will find. You show them a frame and they're like, well, how's it held together? There's no fasteners. And it's like, really seriously, like pretend there's fasteners. No, I need to see them. Okay, so while they were very intelligent and they could really scope stuff out, the lack of imagination was usually the problem here. So you'd right click and you bring them back on and there you go and all that good stuff. So I do, from that standpoint, love configurations. What I don't like configuration is what I'm going to show you here and how we can start burrowing into it. So basically what we have here is we have a couple different choices. If I go to the end frame here and I go ahead and click on it, we will take a look at the fact that we do have the ability of having configurations in there. This is one of the newer pieces of functionality that came through, is that if you pick on it, if there's a little drop down, that has configurations. Now, one of the things you want to notice is that when we change the dimension inside of a single part file, we had to be very careful about where that change took place. If I wasn't thinking, I could change a dimension in a part and it would update it in all the configurations. So I had to be very cognizant. I have to be the same way here when I'm looking at this kind of stuff. If I take a look at it, you can see that I do have a couple of choices in here, but at the end, I do have the ability to make it for this configuration or all configurations or whatever I may need to be. So I'm going to go ahead and keep it on this configuration, and then I can turn this to pine, and I can say, okay. And now I've got a pine side, but this is kind of a mismatch. This is the 3/4 cost one, right? You can have mahogany and pine, and you don't pay as much as the full mahogany. So, and if you color it with a Sharpie, then it looks like mahogany. But someone's going to catch on to that. So I don't want to do that. I need to switch the other side over to the pine as well too. Now this is where we start getting a little bit deeper. The problem that we have here is the configuration hierarchy of how things work. One of the questions I had in the previous session was, what can you do in assembly versus, in fact, I think it was you, sir, wasn't it? So it was, what can you do with configurations in assembly versus parts and, the management. Well, one of the things that I will see people do frequently is they'll double click on a part, change the dimension for one configuration at the assembly from 10 inches to 12 inches, and then they'll wonder why that part's completely messed up in all the other assemblies, and they change it back, but then it's switched here, and it just becomes this horrendous little runaround. And it's a logic runaround on top of that. The problem is that you're not supposed to do that, all right? When you use configurations, your controls are purely at the level that you're using it at. If you're using a configuration in a part, you're only going to control stuff in a part. If you're using configurations in assembly, you're managing features and dimensions, suppression states of only assembly features. A part is an assembly feature, but the feature in the part is not in that realm. Okay, so I can suppress a part, I can modify a dimension that's in a mate, but I can't modify a dimension that's in a part. So it kind of gives you that hierarchy thing. Now the issue I actually have here, we're going to see this briefly, is if I come down here and take a look for the assembly, which is, let's see, not that, this one here. Now I'm going to come in here and you can see it says MHOG, and I'm going to come down and change it to Pine and say OK. And it worked today. Great, that was awesome, SolidWorks. I love it. Now it's going to work, right? So one of the issues that I ran into was that when I changed this to mahogany, it stayed Pine. And I'm like, well, that's not right. It says mahogany. Why doesn't it show me mahogany? And so I'm like, oh, okay, well, maybe I need to dig a little deeper into it. So we can see that if I click on here, there is quite a few configurations in here. And I'm like, oh, okay, so we've got a burner left, a burner right, a plastic, a default, a shelf, a wood, different types of wood. There are actually subs in there. And so what I'll do is I'll come in here and do this. I'll pick on it, and I will simply open it to take a look at it. Now I got into here and I'm looking for those panels. So I look over in the feature manager or the component manager, and I realize that there's actually not a lot of information over here. There's a support frame, axle, and some wheels, and it says nothing about panels. All right, but if I come in here, I can see that there's actually quite a bit of information here going on. In fact, you'll see that I have no active configurations over there, which that actually threw me. I have to say, I got in here, I'm like, oh, it's easy. I'm going to go in here, I'm going to do this, and then I actually sat here for about 10 seconds. And if you know me at all, that's a really long time for me to sit there and look at SolidWorks not knowing what's going on. And then I realize, oh, wait a minute. So I click on here, and sure enough, I see that there's a derived configuration. Derived configurations basically work like this. They are kind of parent-child relationships. So similar to what you get in a feature, like a sketch is a parent of a feature. If you get rid of the sketch, the feature has to go with it. It's kind of the same thing here, except it's with configurations. You're basically forcing information to stay the same, and you have to really go through a couple of hoops to get it segregated out. One location that we use this in is our sheet metal tool. So when you use a sheet metal part, you have the ability to have it formed or you have it flattened. That is a configuration that's made. And if you've ever looked at the file, you'll see it's not another configuration, it's derived. You'll see that it's actually inset under the parent one. And the reason being is that, especially with something like this, if there's a change in the form model, you want that to come through and go into the flat without ever having to worry about it. That's what the derived does for you. So it's kind of a forcing in there. If you ever have these parts, like sometimes you have family of parts that there's certain features you always want to come along for the ride, that's where a derived level will come in. I'll tell you right now, I understand how it works, I know how it works, but I just don't use it. It's a little bit of a too much overhead, and that works for me. That's great. I know how it works, but if I give the parts to you, you're going to like, what? Why did I don't under? And it's just not worth the confusion for you guys at that point. Okay. Now I'm kind of looking here, and I see that there's wood, cedar, and all that good stuff. And if I come in here, what I find out is that there's even goes deeper. And so then I'll come into here and I find out that I have all my different qualities coming on through here as well too. You'll notice the lack of wheels and the lack of anything else in here. So really what we're running into on this is that I have a configuration. In fact, let's just take it one more level. I'm going to right click, I'm going to open the part. And if you look over here under configs, you'll see that the part has different configurations. Pine, mahogany, ABS, oak is in there as well too. Do you see this layer effect coming in? In fact, let me show you here. If I go to Window and I just do a tile vertically, basically what we're doing is there's a configuration in here, which is then put into this assembly, which has configurations calling out other configurations of this part, which is then going into this assembly, which is then calling out the different configurations here, which is calling out the configurations here, going into the main assembly, calling out configurations of configurations of configurations. All right. So what I find is, especially at assemblies, when you have this big diverse quality of things changing, I find out that there's this nice big pyramid of things coming out. You've got one thing controlling a couple things. Each one of these is controlling a couple things. Each one of these is controlling more things. And so you get this kind of exponential growth of communication and configurations coming down. Kind of make sense? So the question we had earlier about when do you hit that cycle of like when should I make a new assembly versus keeping the one in here. On a part, it's kind of difficult. For here, I think there's way too many things. In fact, here, not only do I have 4 different panels that I can put in as far as the material for the panels or the planks that are in there, but I also have a big plastic tray that can go on one side or the other side. And then I also have another one that has a set of burners. And you can have a burner on the right-hand side, or you can have a burner on the left-hand side, or you can have one on both sides, or you can do this. And really what they've done is, just because I have a couple of choices at this top level, I've made it just this bear to manage, because now I got to juggle all these other configurations to make sure everything always works pristinely great. All right. So that's kind of the label there where I say you're probably not going to like it. A lot of times, especially when people start talking, they're like, "Oh, what can you show me?" And I'm like, "Oh, it does this." And they're like, "That's great." And I'm like, "But don't use it." All right. And it's only because there is going to be a frustration level that's going to be involved. Now, are you dealing with this on your own? Are you dealing with it in a group? If you're dealing with it on your own, you're going to find that works really well to go throughout. There's a question in the back.
Yeah, I'm just wondering, in your opinion, many configurations, is it bad because it breaks SolidWorks?
It doesn't break SolidWorks, it breaks us.
It's just confusing.
Yeah, it's just confusing. That's really what it comes down to. Now, if you develop the structure by hand, and this is what I had to deal with this one, I didn't develop this one, and so I get in there, and I know how it should work, and I start clicking things, and I'm like, why isn't it working? And the next thing you know, I'm spending the next 45 minutes deep diving, oh, well, they forgot to do this, or oh, I didn't know it worked like that, I would have done this instead. And next thing you know, 45 minutes go by when I should have just gone in there, double-clicked, and said, yep, ta-da, and then moved on from there, okay? If you're working it on your own, you know the logic that you put into it. Chances are you're going to have a high level of success. It's going to work great. The minute you take that data and you hand it to your customer or you hand it to a coworker and they have to do something with it, I would say get some popcorn, sit back, and watch the ride. Because you're going to see a lot of scratching. You're going to see a lot of sighing. If they have bad habits, like they have to go out and check the weather or something, you're going to see them taking breaks. And then, eventually you can go over and say, hey, are you having a problem, buddy? No, I'm all set. And then you go the next day and, hey, are you still having problems? And finally they're just like, what did you do in here, right? And you can explain it to them and they might get it, but then again, this is your logic compared to someone else's logic. Fair enough? So, good question. I have an opinion for everything, so if you guys want it, I'm here for you. Let's see, what else do we have? Global variables. So, how many of you guys are familiar with global variables? Got one person? A couple people? A little on it? Okay. So the question I have is, how many of you guys, so a show of hands, how many of you guys have ever heard of a configurator before? A couple more hands, all right. So a configurator, for those that may not be aware of what it is, a configurator is basically something that I would develop, so we made custom chassis. We also did fire truck chassis as well too. And so our sales rep was to go out to the firehouse and they would say, hey, what kind of truck you want? And they're like, well, what do you have? And we're like, well, we have 4 different styles of cabs. Okay, here they are. We like that one, so they pick it. And they're like, well, how long do you want it? Well, we want it this long. Okay, we'll pick it. And they're like, what kind of engine do you want? Well, we want that kind of engine. Okay, pick it. What kind of lights? What kind of horn? What kind of seating? How many seating? What style of seating? How many seats? All this stuff. And what it is a big checklist that you could go through, and you made this punch list. You said this, 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 this. And then at the end of that, the configurator, depending on the level, will give you a list or a bill of materials of the items needed to create this particular chassis. Does that make sense to everybody? Now, if you get fancy, what you can do is you can link that to your CAD data, and then when you get this configuration, you can have it ported over to your CAD data, and it would then pull the information together, and instead of just getting a nice little punch list of what needs to go into it, you get a nice little 3D model that's already put together for you. Hopes and dreams crash and cry. So the global variables, what I found that they've been extremely useful for is making a kind of a semi-configurator, something that I don't want it too complex, but it will get me something that's pretty workable pretty quickly here. And so let me go ahead and show you there. And close these out because, you know, keeping 500 files open in Open Assembly seems to work out pretty good in SOLIDWORKS, right? And whatever. And there. All right, we'll take the simple case of cabinet, right? Wait, do you do cabinets? Who does cabinets? What do you do with cabinets?
Yeah, we do steel cabinets.
What company are you with?
Multi-lab.
Okay, so
Do a lot of this stuff with
a lot of
configurations.
customization. Okay, so you're using configurations and design tables today?
Yeah.
Okay, how's that working for you?
Yeah, I've been doing it great.
So far, it's been working okay?
Yeah, so far, I think, and use mostly design tables, and
Okay.
I tried using global variables at one point.
Did it seem to work out okay?
Properties work better as
Okay.
references in the table.
Sure. Yep, most definitely. So this is where I talk a little bit about, you know, there's lots of ways you can do stuff like this. I've seen people set up design tables. I've seen people set up configurations. They all work really well. One of the things I don't like about the configurations is the fact that it does store a lot of information. And while it works great for the first one and the second one and the third one, when you get to 300 and 400 and 500, you're really asking for something bad to happen. And like I said, I do have a customer that's got parts with 400 configurations, and I cringe every time because they actually have 400 drawings of each one of these parts. So not a drawing with 400 pages, but one drawing per configuration. And my question to them with configurations is, what happens when that part doesn't work anymore, right? Now, they have kind of safeguarded themselves. They do regular backups, obviously. They also have a PDM system, so if something does go really bad, they can always go back to that last level where it wasn't bad. So the loss of data has been minimized, but still, that kind of creeps me out. I got one file controlling not just 400 drawings, but think about the 400 other assemblies, if not more assemblies that's controlling as well, too. And not just the assemblies, but the subs and the subs and the subs and all that stuff. I mean, I have one part file that's literally controlling almost 800 to 1,000 files out there. That kind of gets me a little whatever, you know. So once again, we talked about this earlier. Looks great on paper. Sounds great when we talk about it. Is horrible in a practical sense. So we're asking for problems and stuff. So the global variables are something that I kind of like. In fact, I'll kind of show you some back data here, and then we'll show you what I got and how I got there. But I do have a current, let's see, go ahead and escape out of here. And I have someone that I'm kind of working with right now. And we'll take a look at this. So I have a manufacturer of insulation. So you go to a factory website, or you go to a factory or any kind of large industrial site, and there's a lot of these sleeves over some of the pipes and stuff like that. The problem is like if it's over a valve, you have to replace the valve every often. You get corrosion on it, all kinds of things. Well, if you have a hard insulation on it, you have to bust through the insulation, and then you got to take the part out, and then you got to put the new part back in, and then you got to re-insulate it. So what they make is a removable insulation. It's kind of done with buckles and Velcro and all that good stuff. Works pretty good. Now the thing is that they had a program that basically when they got a new order, it took them about 5 minutes to create not just the new part, but to flatten this out and throw it out to the Gerber machines to print out the cloths or cut out the cloths and sew it all together and stuff like that. So they would get an order in, and in 5 minutes it would pop up and they had all their drawings ready to be sent out. They went the 3D route because they thought it would be a little bit nicer, and so what we did was we came in, we showed them that it could work for them, we showed them how we could flatten the stuff out, and they could get a little bit more customization involved. Now, in a case like this, what they wanted was the same kind of controls they had in this other package, which was basically just a little punch list that they could type in. So what I ended up doing was this, is if I come over to equations, you'll see that the little punch list is on the left-hand side. Information that they had to put in. They had to know the inner diameter. They had to know the thickness of the insulation. They had to know how many panels they wanted on a curve like this. Did they want 3 panels, 4 panels, 5 panels? What did they want? So we went through, we gave them all the information that they control. This is literally what their controls look like in the other program, and it looks like what it looks like on the paperwork as well too. And ultimately what I ended up doing was this, is if I take a right click and manage those equations, this is going to kind of show you what's running things in the background. Now, I will say this, one thing I'm not happy about with the equations or the use of global variables, I would love to be able to go to the left-hand side here and just modify these numbers. You can't do that. You have to modify the equation to get to these numbers. Once you get here, it's actually kind of okay. And if you have a larger screen, it actually works out pretty good too. So I'll shrink this up a little bit here, and you can kind of see in the background as things will progress through here. But, you know, if they come in and they find out that the inner diameter is 6 inches, they can just type in 6 and it's instantly going to update there. If they find out that because it's smaller, more panels might work out better, they want to go 6 panels, they can go ahead and throw in 6 panels there. So it becomes very easy for them to just open up this part. In fact, what I did was I set a part file up with all this information in it, and then what I did to make sure that they could always use it was I saved it as a template. So now what they do is when they get a new order for an elbow, they go File, New, pick the elbow file, open it up, edit the manage the equations, and then just start typing the numbers, say OK, and they're all done from there. Okay. So from beginning to end, we're looking at about 3 to 3.5 minutes to do it compared to their 5-minute system, and it actually has been working pretty well for them so far. All right. So how did we get to this level? Well, basically it comes down to this. I'm going to go ahead and cancel out here. It's going to revert it back. And I'll get back into here. Now, this is a little bit of cheating, I guess I should say. All right. Now, one of the things you'll notice is I have a standard part, or I have a stock part that I do here. I'm guessing you guys are in the same thing. As people will call you up and go, I need it this wide, this tall, this deep, right? So that's kind of what I want to control here. What I have is I have a kick area underneath. I want to control the height of. I have the depth of it. I have the width of it. I have the, you know, how tall it is and all that good stuff. And so what I did here is I used an assembly for this. This isn't quite top down. What you'll notice is all my parts have square brackets around it. This is a single file assembly. All the parts live inside of it. So how many of you guys are familiar with what we call a virtual component? Okay, a couple people. So a virtual component inside of SOLIDWORKS is a part that doesn't have a part file connected to it. It resides within the assembly file itself. I find it very, very useful for a couple things. When I do machine design or something like that, I have to go to Bimba to grab an air cylinder, and they make beautiful parts because I go there and I download an air cylinder and I open it up and I get a beautiful assembly with wipers and this and that and 20 parts just to make this assembly. The problem that I have with that is that I have to manage that, and I don't want to manage all that data. I don't want to manage the assembly and all the parts. So an easy way around it is once you import this assembly and you open up the assembly, take all the parts, right click on them, say make virtual, and it pulls all the data into the assembly, and you can literally take the part files, check them out. Now I have an assembly file, a full functioning assembly file that has all the parts embedded into it. I never have to worry about controlling those other items. Kind of make sense there? All right. If you go to the DASI Solutions website, there is a blog. I have a whole write-up of the steps involved with that and how it works out and what happens in there. So you had a question, sir?
Doing that virtual parts, can you then have different configurations of your cylinders, say extended and retracted?
Yeah, absolutely. That's what I liked about it. The trick at the time, shows you how long ago I did this, the trick at the time before we had virtual components is I took the assembly and I saved it as a part. And then I could maybe do some stuff with configurations. The thing I missed was I couldn't get dynamic motion. Like if I wanted to raise something up through its range of motion, I couldn't do that. And it's one thing to say, here it is open, here it is closed, but it's as it was closing that you see that it hit something, and I could never get that. You have full capabilities. In fact, this is what I've done here, is these parts are all virtualized. If I right click on the part, just like I would in a normal assembly, that's a virtual component. I can add features to it. It's full functional. There's one downside. You want to see the downside? If I come over here and say File, make drawing from part. That's the one thing you can't do with the virtual component. You can't make a drawing of a virtual component. You have to have a real file. The way you do that is you simply right-click on the file and say, save to file. Now it creates a new file at that point. Make sense? Now, I did it this way because I knew everything in here was going to be changing. I'm also going to go on the supposition that I don't have common part numbers. I'm simply going down the fact that I have production numbers. So this is where it kind of falls apart. But what I found is that managing a single part file used in multiple places sometimes becomes more expensive than just creating a custom part per job. So it's one of those things that I do have people that come up and go, oh, well, we make single... Plus lunchtime, let's go. All right. I do have customers that will have, they won't use our weldment tool because they're using part numbers, because everything, the 32-inch pipe is this part number. And if I use it here, it's that part number, here it's that part number, here it's that part number. It's a weldment, so I kind of, in my own head, I have an issue getting beyond that. Once you weld it all together, who cares what that part number for the tube was? If you get it so that I have a punch list and you got a guy cutting it out there, I guarantee it's way cheaper than trying to manage a part number. The only thing is, you really got to do a big ROI on it at that point, okay? So keep that in mind. In this particular case, what I'll do, I'm going to go ahead and close this down. We'll take a look at what I did. And really what I did was this, is I'm going to go up and just hide these out so we can see what happened in the background. And I come here, and this is how it all started. Or I can hide those. That works out good, Ryan. You did awesome. One of these will work. There it is. So I created a couple of planes, and all these planes were based off of this initial three-dimensional sketch. So all the 3D sketch did for me is it created a block. And if I take it and right-click and edit it, this is what went into it. Okay, so I got a width, I got a height, and what I did in my own head was said, hey, these are going to be the outside dimensions of it. Kick plate on the bottom, or the toe board on the bottom, you'll see is set at 4 inches. I've got a depth, I got a width, I got a height. Everything is great from there on out. Now, when I got done with that, I set up a couple of planes, the left side, the right side, and the back side, because I knew I was going to use these for setting up my new panels that were going to be going in here. And then I simply created each panel one at a time. I insert a new component, and nowadays if you insert a new component, it's going to come in as a virtual component at first. So if you guys have done any top-down design recently and you created a brand new part in your assembly, you have dealt with this virtual component. The downside is, if you've done this and you didn't realize it, you need to go back and look at your stuff, all right? Because you might have some issues there. Now, if I right-click and edit the sketch of the panel on its own when I open it up, you notice there's not a lot of information going on in here, all right? And that's because what I did was I referenced the sketch assembly that I created at the, or I related myself to the sketch in the assembly for sizes, depth, all that good stuff. So ultimately what it comes down to is if I come over here and I want to make a change to any of these panels here, all I need to do is go to that original sketch, double click on it, and I can make it 30 wide, I can make it say 40 tall, and then I can make it less deep, and we'll go ahead and make it 32 deep. I do a rebuild, and there's the change. All the parts have updated at this point. I'm all good to go. Now the thing is, I don't want to have to get into the sketch, double click and show it and not show it and all that good stuff. So what I'm going to do is I'm going to use those global variables. I'm going to connect everything up to a global variable, and then I'm going to go the next step farther and say I'm making a configuration part. Not making configurations, I'm going to make a configuration part. That means that when someone calls up with this new idea or new pan or new cabinet, all I do is I go File, New, what's the numbers? Click, 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 click. Okay, done. Save as. I'm all good to go from there. Okay, so I come in, I'm going to go to Insert, Tools and Equations, because that makes sense. And we have a blank slate right here that we get to deal with. And what I have is global variables at the top. You have features, there's equations at a top level, and there's also equations at a component level as well too. If you really want to confuse your coworkers, use that function. It works out great. Basically, it's an almost invisible top-down link. and it drives me nuts because I've had this come in and bite me in the butt, and I can't figure out what it is until someone's like, oh yeah, I put the equation up at the assembly level, and then they got new racing stripes on their cars, and I got some paint on my keys. That's all I can say. So, global variables, basically put them in at the top. Idea here is that you want to give it a name, you want to give it a value, and you want to put a comment in. What would be the reason of putting a comment in at this area? Any ideas? Bueller?
Remind you later.
Reminds you later. Yep. If I work with a group of people, it's good to let them know what it's controlling. I have literally seen people. I had a coworker made this beautiful equation, had these great design tables, and they were contracted in, and he did all this work, and he showed it to me. I'm like, this is awesome, man. I can't believe this is great. He only put like 2 hours worth of work in it. Let's put it in context here. When the other people had to modify this part, they were usually on it for 45 minutes to an hour and a half. This guy put 2 hours worth of work into it and automated the whole thing. If you needed a change, you went in, you made your modification, you said update, done. Everything was done. He was later let go, and because he was contract, and then the other guys who had never been classically trained or even taught went back to their old ways of going, I don't know what's going on here, delete, and then they deleted it. It was very sad to see that. So put comments in so that it can help people. If anything, the comment may be, do not delete, talk to me. All right, and that way they'll come talk to you. So I'm going to come in. We got to give it a name. There are certain names that are out of bounds to you guys. All right. So one of the ways that you can tell is if I were to say, come in here and try to type, say, thickness. Try to learn how to type, apparently. Oh, thickness is going to work today. Never mind. Maybe it's because I capitalized it. It doesn't know it. Yeah, let's just cancel out. There, see, I knew it was going to do it to me. All right. It might actually work here. I know if you're in a part, thickness won't work. And the reason being is that when you create a sheet metal part and you define the thickness of the sheet metal part, that actually becomes an automatic global variable. So if you guys have ever created a sheet metal part, never noticed it, look over and you'll see that there is an equation folder available automatically. And if you click on it, you'll see thickness equals whatever the gauge thickness you're using. All right. So assemblies might be different. I'm going to go ahead and just put in some standard stuff here. So width, and I'm going to say that width is equal to, we're going to say 28. And then I'll do this, controls width, duh. And then we'll go ahead and put the height in here. And the height is going to be equal to, say, 40. And the guy who makes counters is probably like, oh my god, that's just too big. And then we'll put depth in here as well too. And the depth here will be 32. And then we'll put the kick toe or the toe area, toe R. All right, looks like we're screwed there. And then we're going to make that as 4. So this is a do as I say, not as I do. Make sure you put your comments in. And that should work out pretty good. You can also do equations here. Technically, you should be able to make equations from scratch in here. I've never been successful, and I think that's a little bit crazy as well too. To get rid of this table here, work with the part directly, you're going to be way better off. So I'm going to go ahead and accept all these at this point. And if I come over and take a look at my equations here, I'll see that I've got height, or width, height, depth, and toe area. It's that's what they say in Maine. So there. Yeah, it's a pirate. All right. Am I done? I've created these global variables, but now what I need to do is I need to hook something up to the global variables. This is one of the reasons I did this at the assembly. I could probably get away trying to figure out how to hook up a number in a component up to this dimension or this global variable in assembly, but it's not going to work out real well. And really what it comes down to is it works fine in the package. The failure becomes the meat inside of our head at that point. So it's not something I would say that you would want to do unless it's just you controlling it and you're very specific on what you want to control with that. So what I'm going to do here is I'm just going to go ahead and I'll right click and edit the sketch. And that way it brings up the dimensions, and then it's pretty straightforward from here. So this one would dictate the height there. So I'm going to double click on it, and just like all equations, everything starts out with an equal sign. All right, once you do that, you're going to be given a couple choices underneath. You have global variables, you have functions, you have all kinds of things in here. So I'm going to say it's equal to the global variable height. Say okay to that, and that number is already changed. We'll say here this is going to be for the width, so equals global variable width. And yes, if you know what you wrote in here, you can put equals, quotation, the name, quotation, and you can actually connect it up. You don't have to pick it from a list if you don't want to. So I'll accept that one. You can see that the sketch is already updated. I got the toe plate area here, R, and then we'll hit equals. And then we'll do the last one here, which is the depth. That's going to equal the depth. Now, you'll see that it was slightly shifting a little bit as well, too, as some of the numbers realign themselves. And that works out great. As soon as I get out of it, the cabinet's already sufficed itself. It's all good to go. So what I've made here is a single source destination. I get a new part number in, or I get a new project in. I simply come over to equations, manage equations, adjust the volume, the numbers as necessary, and I'm all good to go. All right. That should be about how simple it is. Let's take it that next step. So I'm going to go ahead and say okay to this. And then I'm going to do this. I'm going to go File, Save As. I'm going to save it as a template. And then I will save it in the regular area there. Oh, see? Dang it. So the issue, what did I run into? Well, apparently, the assembly doesn't like my top-down design. And I now get to put in a nice little thing to SOLIDWORKS for an enhancement request going, hey, I really need to do this, all right? What I need to do here is I need to be able to save an assembly that's got virtual components, but SOLIDWORKS is still detecting that it's referencing external files. I've already seen the fact that everything's held internally here. So my plan really falls apart at this point. And this is one of those things that drives me up the wall because SOLIDWORKS has been around for so long that, man, why doesn't it do this? So I've led all of us down this glorious path of how this is going to work for us. All's not lost. I will tell you that right now. The fact of the matter is that because the components are virtualized inside, I really have now a single source file that I can go to. I can't make it as sexy as going file new and going from there, but I can come in here. I can do a regular file save as. I can come in and say it's the new cabinet. Wow. And then we can go ahead and take it from there. Because the parts are virtualized, your internal contacts stay the same. Everything works out great. The beauty of the whole thing is once you get done and you need to create drawings of each one of these parts, that's the downside. You simply come in, you right-click on a part, and then you say Save Part in External File. That's going to pop up. It's going to ask you what you want to call it. You go ahead and save it out, and you're all good to go from there.
You did first set of file before you did the save as?
What's that?
Is this the second file you did the save as?
Yes, this is the new cabinet. I'm sorry, it's a little bent up back there, but this is the new cabinet.
Yes, but does it have to be, does the original cabinet have to be saved? Is it still linked to it?
No.
You can erase it?
No. Oh, well, you could erase it, but really what that becomes is a start part for me. So I'll take that as a regular assembly file.
Yeah.
And I will open it up, say File Save As. I'll leave the natural one there because that's my original one. And that way I've got a new file I'm working with. Change all my sizes I need, send it out to get it cut.
Okay, so you're going to keep the whole file?
Yes. Yeah, this would be like my new project.
Okay.
And then next week I get another one, and I'm going to go back to that original file, open it up, save as, and now I've got this own file. The problems that we used to have traditionally is, especially with top-down design being involved, is that when you change the name of that original file or you save that original file as something else, all your external relationships broke. But because we're keeping the parts virtualized, they tend to keep that a little bit nicer. I don't have to go through the traditional window or the SOLIDWORKS Explorer rename and hope to hell everything works right type thing. The virtualization helps kind of compartmentalize that idea there.
When you send it to your customer or work with, you have to send the original plus the save?
No, they are not connected together.
Okay.
Yeah, there is no link between the new save as and the old original one. So yeah, no, you can just send them the new data. This actually works out a little bit better too, because if they have SolidWorks, I only have to send them a single file. I don't have to make sure I do the pack and goes. And obviously there would be more information in here. I might have bracketry that I use to, screw everything together. Well, the bracketry doesn't have to be made internal or made as a virtual component, because I can have it reference the original parts that I use as a standard bracket. So that's where you can kind of start to intermix these things and stuff like that. So really what it comes down to, the downside, the things I've run into before is, why can't I save this as a template? Oh, it's got external references. No, it doesn't. Everything's inside the assembly. I don't need to do that. So that's where it falls down at. So now we get into the save as state. Ultimately, this is, you're beginning to get into the configurator itself. Now, something a little bit that is beyond this, and what makes this a little bit more advanced than what we showed previously, is we can get into what's called, under tools here, and we have the express tools, is the DriveWorks Express. Has anybody heard of DriveWorks before? 1, 2, 3 people? Okay. DriveWorks is a configurator for SolidWorks. Now, you'll see it does have this DriveWorks Express, and basically it is the full tool, but it is kind of, it's handicapped a little bit. They've taken some of the functionality out. Unlike the Flow Express and the Simulation Express, they've taken stuff out of the DriveWorks, but they haven't taken out enough to completely yeah, I kind of see what you're trying to do there. You can still make a fully functional configurator in here. In a case like this, what I would do is I would end up taking this part, connecting it up into DriveWorks, which is, it's not a Excel-driven database, but it's a database-driven type thing. And you go through this nice little rigmarole. There's beautiful help files that are in here. But basically what it ends up doing is kind of what I'm trying to do here. I end up making a user interface through DriveWorks. So instead of opening up the new file, I go into DriveWorks, go, I need a new cabinet. And it pops up my user interface, and I type in my numbers, and I say, okay. And what I've done is I've taken some base files in the back, kind of what I've done here, and it does all the saving and all that good stuff, all the making of prints, everything. So one of the things I would say is that if you get into a situation where you're looking at this in particular, you make a lot of these cabinets, and you said you tried to use the whole, global variables, didn't work out so well, and now you're going down the whole design table path.
Yeah, I could use custom properties the same way.
Right, yeah, up in the custom properties and push it down.
I put in the length, width, depth.
Yep.
It calculates what part numbers and what the dimensions are supposed to be.
Okay, so yeah, you got something pretty in depth there. So, the DriveWorks is kind of designed, it's a design table on steroids is really what it comes down to. DriveWorks worked great. I went into a customer, they had slide outs for RVs, and basically what it is their customers could call up and go, I need a slide out that's this wide, this tall, this deep, with a motor position at this level, and I want it this color. So there was 5 things that the customer could call up and control. So they call us up, they're like, we've got something set up, it's taking a little bit longer than we want it to, can you come in and help us make it faster? So I hear about what they're trying to do, and I'm like, top-down design, I got the save as, man, we're going to get this cool and everything. So I go in there, I'm like, well, show me what you got. So he opens up assembly with top-down design and does save as, and everything I was going to show him, he'd already done. So I'm like, oh, okay, let's figure this one out. So thinking on my feet, I go, let's try DriveWorks. Now, my history of DriveWorks is this. Back in 2001, 2002 was the first time I was introduced to this program. I knew what it could do. I understood what it could do. I played around with it for about 10 minutes, and I thought, wow, that's pretty cool. We'll jump to, that was 2001, 2002. Let's jump to 10 years later, and I'm standing on someone's doorstep, and they go, I need this faster. And I'm like, DriveWorks, we'll do it. I'm like, sweet. And I sit down and realize I don't know how to use DriveWorks. So I kind of knew what was going on. I took his assembly. There's some things we had to change in order for it to work correctly. It took about 3 hours to do that with all the parts and pieces, made sure it worked good. And then we took it, and on the fly, I basically put it into DriveWorks and figured out how to use DriveWorks on the fly. The cool part is, once you learn a couple things inside of DriveWorks, you realize it's a very repetitive thing. So you just got to learn the main steps, and it's like, oh, it's this, click, click, click. And guess what? It's really similar to a design table at that point. So you start going, I need to control this, and here's my values, and here's my checklist, and here's that. And so we got done, and we put about 7 hours worth of work into this, and we got done, and we used it once, and I could generate a print within, it came out to 1 minute and 55 seconds. Now, it took him 15 minutes to generate a print previously because they had to open assembly, modify, do the save as, modify the references, and then they went through and made the changes, and that updated everything, and then they opened the drawing, and they rechanged their references over, and then they saved the drawings off, and then finally 15 minutes later they can make a change. So I get done with this. It comes up in a minute and 50 seconds, minute 55 seconds, and he goes, okay, well, what does that do for me? And I'm kind of like, am I missing the boat here? Like, dude, it's like went from 15 to almost 2 minutes. Like, I thought that was pretty good. Really, here's what it came down to. We made a user interface. That's the really the beautiful part of DriveWorks, is that you make a user interface. And it could be drop downs and verified and validated cells and all kinds of good stuff. In fact, you can make it so if I pick this, it does this, and only these choices are available. You can put some real great intelligence into it. I called the lady that I had seen working the telephones up front. She was reading a magazine at the time, and that's what I kind of seen her doing most of the day. Brought her in, showed her a sales, the sales order with all the numbers we needed, and I said, here's a list of instructions. You have to click here, you have to click here, you have to click here. And so she followed the instructions, and then the window, the user interface popped up. So she was in SolidWorks. The user interface popped up. And she goes, okay. And I go, what does that look like? She goes, it looks like the sales order. I'm like, what do you think you should do here? She was like, well, I can put the numbers in here. Oh, there's a drop down. I can drop. Oh, yeah, look, yellow. That's where it's at. And so she got done with it. And at the end of it, she goes, well, do I just hit this button? I'm like, what do you think? She goes, yeah, it says finish. So she hit finish. A minute, 55 seconds later, prints and everything started coming out. They were saved onto the area where they were saving the data at and everything. And then I looked at him. I go, you don't need to have a SolidWorks user do this stuff anymore. Anybody could do this as long as they have access to the program. Fair enough? Now, that's what the Express tool does. The only downside that I found with the Express tool was that it would not rename the dimensions. So, after a minute, 55 seconds, you had to then do a slow double click on the drawing because the part was actually named correctly, and you just had to update the file name of the drawing to match it. That was the downside. All right. If you wanted to name your own drawings, if you wanted to make it so someone doesn't have to get in SolidWorks, you'll look into the bigger portion, the bigger DriveWorks at that time, and they've got various levels, including levels all the way up to the point where your customer doesn't send you squat. They go to your website, they fill in the data, and for a premium, they fill in their own data and hit finish, and then their prints come out on your site. So you charge them more for doing your job for you. Ta-da! All right. Well, that's not right. Oh, questions and possible lies. So, it'll be up to you to figure out if I'm lying or not. And then I may have answered it at the previous presentation, but there's only one person here that wouldn't really know that. So if he asks a question and I say that, just go along with it, all right? Tootsie Rolls. So, any questions? Anything? Bueller?
As far as the bill of materials, I've run into, just an example, say I have 2 cylinders. It's the same cylinder, but I'm showing one extended and one retracted.
Yeah.
When it comes time to put the bill of material, I can't seem to get the option to say, okay, it's the same part, count it as quantity 2.
Are you using configurations for the open and closed?
Yes.
Okay. One possible way around it is to use flexible subassemblies at the main assembly level, but that's a whole nother presentation. That would work because technically it's the same assembly, so it would be counted twice. What you would want to do is in your configurations of the subassembly, make sure you have your options turned on to force it to count it as the same number. There's also options in your bill of material that will, so do you know what I'm talking about?
No, not at that.
Okay.
I mean, I'm trying every option under the bill of material.
Yeah, no, so if I come in here and create, actually if I just look at the properties here, this is actually, child component display when used as subassembly. So, do you hide it, mode it, show it? Up here you have part number displayed when used in bill of materials. You can actually force this to be the same name. And then there is an option in your bill of material that you can tell it to look at certain things, count it together. Yeah, exactly. So if you have 2 different configurations, you might want to tell it to be the same thing. Now the thing is you might be able to tell it just to go to the document name. So there's a couple things that are going on there. What I would say is if you're having issues with that, who's your VAR? DASI is? Okay, so we are, all right, and then you're with who?
Quality machine.
Quality Machine. Oh, you're one of our new customers, right? No, you've been with us for a while? Someone newer?
Couple years.
Yeah, okay. If it's not working right, give us a call on the 800 number, all right? And then I'll have my email address at the end, so if you want to shoot me an email, if I happen to have a chance, I might be able to take a look at it and see if we can't figure it out on the phone, all right? So, but yeah, that's the other thing. You get into some dicey situations with bills of material, and sometimes it's a little tough to manage it.
That's when I use configurations is I'll make a BOM configuration and then I'll have it mode and I'll put all this, just for that bill of material,
Right.
all the cylinders in using the same configuration.
Yeah.
That way it rolls up my quantities correct.
Yeah, most definitely. So, yeah, we can definitely take a look at it. So, if you're having that issue, let's just give us a call and we'll take a look and see what we can do to help out. So, any other questions?
Isn't Toolbox just a whole bunch of configurations?
Maybe. Oh, I can't use that here, can I? Oh. Toolbox by default uses configurations, although there are options inside of it that when you create, like say you pick a size, it has the ability to save that out as it's its own part. And I would say that if you guys are integrated in with a PDM system, a product data management system like Enterprise or even the new Enterprise Standard or Standard PDM, we actually suggest that you go to the part for part thing as opposed to the configurations, only because there's this check in, check out process in the background that has to happen. So it's easier to take a new part, check it in. So we go back to do I want to deal with a part with hundreds of configurations or do I want to deal with 100 parts? We find out that dealing with 100 fasteners inside of a PDM system with search capability and all that good stuff ends up being a little bit nicer. So it does use configurations, but it does have options not to. So. Anything else? Nothing? Jay, is there anything here? I did. All right. We'll go ahead and call it a day. Thank you very much for your time. I appreciate it. Let me go ahead and put up at the bottom I do have Ryan at DASI Solutions. So if a question pops up, feel free to get a hold of me. I'm more than happy to help you guys out, or if we need to discuss something, or if you want me to see something. So yeah, definitely get a hold of either me or call tech support. That'll work out. So, and if you're not a DASI customer, shoot me an email. I don't care. I'll help you out. I'm a nice guy at that point. So, sound good? Thank you very much, guys. Appreciate it.